Hello friends, today we're going to be doing our only notes on force and motion. This is a very quick unit and you have a paper that looks like this. You're going to glue it on the back and glue it in, and then we will come on back and do our notes. All right, so force and motion. Force can change the movement, the shape, or the position of objects. Okay. Force is a push or a pull that may or may not result in movement, depending on how strong the force is. If a force is not strong enough to go against friction, which we'll learn about in a little bit, then it will not move. The force will have to be enough to be able to move that object. All right, we're going to go in here. Magnetism. We're going to talk about magnetism. Magnetism is when opposite poles attract. Remember we talked about opposites attracting? The same thing. And light poles repel. So south and north are going to attract, and like poles will repel. So magnets only stick to the following things: steel, iron, nickel, and cobalt. Now this is called a magnetic force. Magnetism is a magnetic force. It pulls things together or pushes things together. So magnets will only stick to steel, iron, nickel, or cobalt. All right, the next force that I want to talk about is gravity. Gravity pulls to the center of the earth. So it holds objects onto the ground. Without gravity, we would be floating in like we would in space. So gravity is pulling you down, holding you down. That force is being pushed down onto you, and so gravity goes toward the object. Friction is the force that stops something from moving. It slows or stops motion of an object when they rub together. The rougher the surfaces are, the harder they push together. Which means there will be more friction. So if a ball is rolling, gravity is holding it down to the ground, first of all. And then we have rough, like a grass. The ball is rolling and it's going to slow down because the rougher a surface is, the quicker it's going to slow down, because the force of friction acting upon it, moving this way, is going to slow it down. Now, if we have a smooth surface, or the smoother the surface is, the less friction we have and the less force acting upon it, so it will move further or faster than it would in a rough surface. Here we have more friction, and here we have less friction. Let's see. I'm going to go in the middle. A force is a push or a pull, and it's measured in newtons. Like we measure temperature in Celsius or Fahrenheit, we measure it in newtons, which is a capital N. So if I go over here, and we're talking about unbalanced forces. So if I have 3 newtons going this way and 4 newtons going this way, the side with the most force is what is going to be pushing. So it's going to move this way because this is unbalanced. And when it pushes this way and it has a larger number or more force, it's going to move in this direction. Now, if this was 3 and this was 3, it wouldn't move anywhere because they would just be pushing against each other with the same amount of force. If this was 4 and this was 4, they wouldn't move. So if I had a higher number here like 5 and we were pushing against the 4, it would move in this direction because we have more force going in that direction. So when you find net force, you're going to find the difference. It is going at 1 Newton because it is 1 Newton more in that direction. So here's an example of a push. A push is writing with a pencil. Or a bulldozer pushing dirt, closing a door. Those are all pushes. Now a pull is going to do the same thing, except a pull, you are pulling in you are pulling a different direction. Let's see here. So I have 8 going this way and 5 going this way. So it's going to move in the direction with a larger force, this way. Okay, so my net force is going to be the difference. It's going to be 3 newtons. Examples of pulls would be pulling a wagon, opening a door, if you're pulling it towards yourself, brushing hair, because you're pulling it down, picking something up, like books. Those are all pulls. So the main thing that I want you to take away from this is that a force is a push or a pull. And if you have balanced forces, equal force on one side and then the other side, same amount of newtons, and they're not going to move anywhere. If they have different, then if it's a pull, it moves in the direction of the arrow, whichever one the larger newton, so this would be the larger newtons, whichever direction that arrow is moving is where the force will go. So it's here, and on this side, the 4 newtons is going in that direction. That's why it's on this side, because it's pushing in that direction. I also want you to know that magnetism is a force, a magnetic force, gravity is a force, and friction is a force.